Ah, the sun. It hangs in our sky, a familiar sight, yet its power is almost unimaginable. Every single second, the sun converts about 4 million tons of its mass directly into energy. Now, that's not a small number. It's a colossal amount of power being released constantly. This energy radiates outwards through the vastness of space in all directions. And it's this outpouring that defines our star and makes it the brilliant object we observe. The sheer scale of this energy production is, well, difficult to comprehend, a testament to the forces at play within its core. It's an engine of unimaginable ferocity, burning brightly for billions of years. Imagine trying to create something as bright as the sun. It's simply not possible with our current technology. The brightness is so intense that looking directly at it can harm our eyes. This immense luminosity comes from its incredibly high surface temperature, around 5,500 degrees Celsius. But the core? It's far hotter, millions of degrees hotter in fact. The light and heat generated are the lifeblood of our solar system. This brilliance has fascinated humanity for millennia, inspiring myths, religions, and of course scientific inquiry. It's a constant presence, a daily reminder of cosmic power. Our sun is a star. It's our local star, the one closest to Earth. There are billions upon billions of other stars in our galaxy, the Milky Way, and there are billions of other galaxies in the universe. Each of those distant stars is also a sun, perhaps with its own planets, but this one, our sun, is special to us. It is the central point around which our entire solar system revolves. It provides the stability and the energy that makes our planetary neighborhood what it is. It's a G-type main sequence star, often informally called a yellow dwarf, though its light is actually white. So what makes this celestial giant shine so fiercely, day after day, year after year? It's not a giant fire in the way we understand fire on Earth. There's no wood burning, no coal being consumed in the conventional sense. The process is far more fundamental, far more powerful. It involves the very building blocks of matter. Understanding how the sun shines reveals some of the deepest secrets of the cosmos. It's a story of transformation, a story of immense pressures and temperatures found deep within its heart. This constant shining is the key to everything in our solar system. The secret to the sun's enduring light and heat lies deep within its core. This central region is a place of extreme conditions. The temperature there is estimated to be around 15 million degrees Celsius. The pressure is also immense, over 200 billion times Earth's atmospheric pressure. It's hard to truly picture such an environment. These conditions are so intense that they force atoms to behave in extraordinary ways. Matter exists there as a superheated plasma, a sea of charged particles. This core is where the sun's energy is born, a true powerhouse of cosmic proportions, driving everything we see. In this incredibly hot and dense core, a process called nuclear fusion takes place. This is the sun's engine. Tiny particles, the nuclei of hydrogen atoms, are forced together. They overcome their natural repulsion due to the extreme pressure and temperature. When they fuse, they form helium nuclei. This process is not a simple joining. A tiny amount of mass is lost and converted directly into a tremendous amount of energy. This is described by Albert Einstein's famous equation, E equals mc squared. It means energy equals mass times the speed of light squared. Even a small amount of mass creates vast energy. This energy, born as gamma rays in the core, doesn't escape the sun immediately. It begins a long and complicated journey outwards. The photons of light bounce around inside the sun, being absorbed and re-emitted by atoms countless times. This journey can take tens of thousands or even hundreds of thousands of years. It's a slow, meandering path from the core to the visible surface, known as the photosphere. Only then can the light finally escape into space, traveling unimpeded towards Earth and the other planets. This random walk of photons is why the light we see today was generated long ago. So, the sun shines because it is a gigantic nuclear fusion reactor. It is constantly converting hydrogen into helium in its core. This process releases an incredible amount of energy. This energy eventually makes its way to the surface and radiates out into space as light and heat. This is why the sun has been shining for billions of years, and it will continue to shine for billions more. It's a stable, long-lasting source of power, a direct consequence of fundamental physics operating on a grand scale. Our very existence depends on this continuous, reliable nuclear furnace. The sun is not just a source of light and heat, It is the gravitational anchor of our entire solar system. Its immense mass, which accounts for about 99.86% of the total mass of the solar system, creates a powerful gravitational field. This gravity is what holds everything together. It dictates the paths of all the planets, from Mercury closest in to Neptune far out. Without the sun's gravity, the planets would simply drift off into the cold darkness of interstellar space. It's the invisible force that orchestrates the celestial dance of our planetary family. This gravitational influence extends beyond the major planets. It governs the orbits of dwarf planets like Pluto. It controls the vast asteroid belt found between Mars and Jupiter. It steers the icy comets on their long journeys from the outer reaches of the solar system. Everything is bound to the sun. Its pull creates order from potential chaos, ensuring that the planets follow stable, predictable paths. This stability has been crucial for the development of complex systems, including life itself on planets like Earth. The sun's gravity provides the framework for our cosmic home. For life on Earth, the sun's role is absolutely fundamental. The energy it provides warms our planet, keeping temperatures within a range where liquid water can exist. Liquid water is essential for life as we know it. Without the sun's warmth, Earth would be a frozen, barren wasteland, incapable of supporting the complex ecosystems we see today. The sun's light also illuminates our world, driving weather patterns and ocean currents. It shapes our climate and makes our planet habitable. It is the primary driver of Earth's dynamic systems, creating the conditions necessary for life's emergence and evolution. Furthermore, sunlight is the direct energy source for most life on Earth through a process called photosynthesis. Plants, algae, and some bacteria capture sunlight and convert it into chemical energy, producing oxygen as a byproduct. This process forms the very base of the food chain. Animals eat plants or eat other animals that have eaten plants. So, ultimately, almost all life on Earth is solar-powered. The warmth we feel, the air we breathe, and the food we eat can all be traced back to the energy produced by our magnificent star. It is truly the giver of life. Despite centuries of observation and decades of intense scientific study, the sun still holds many secrets. We have learned so much, yet there are phenomena that continue to puzzle astronomers and physicists. One of the most intriguing is the coronal heating problem. The sun's visible surface, the photosphere, is about 5,500 degrees Celsius, but its outer atmosphere, the corona, which is visible during a total solar eclipse, sizzles at temperatures of millions of degrees Celsius. How the corona gets so much hotter than the surface below is a major unsolved mystery in solar physics. Then there are the dynamic and powerful events like solar flares and coronal mass ejections. Solar flares are sudden, intense bursts of radiation, while coronal mass ejections are massive eruptions of plasma and magnetic fields from the sun's corona. These events can release enormous amounts of energy equivalent to billions of atomic bombs. They can travel through space and impact Earth, potentially disrupting satellites, power grids, and communication systems. While we can observe them and understand some of the underlying physics, predicting exactly when and how powerfully they will occur remains a significant challenge for scientists. Sunspots are another fascinating feature of our star. These are temporary, dark, cooler regions on the sun's surface caused by intense magnetic activity. The number of sunspots visible on the sun varies over an approximately 11-year cycle known as the solar cycle. This cycle also influences the frequency of solar flares and coronal mass ejections. While we understand that magnetism drives these phenomena, the precise mechanisms behind the generation of the sun's magnetic field and the workings of the solar cycle are still areas of active research. There's a deep, complex magnetic engine within the sun we are yet to fully comprehend. In conclusion, the sun is far more than just a bright object in our sky. It is a colossal nuclear furnace, the gravitational heart of our solar system and the ultimate source of energy for life on Earth. Its brilliant shine is a product of fundamental physics, transforming mass into energy deep within its core. Yet, for all we know, our star continues to present us with profound mysteries, from the scorching heat of its corona to the unpredictable nature of its outbursts. The sun's enduring brilliance and its enigmatic behavior remind us that there is still so much to learn about our closest star, a constant beacon in the cosmos.